Welcome back to this free training series on FEMA P-154, Rapid Visual Screening of Buildings for Potential Seismic Hazards, brought to you by the Federal Emergency Management Agency's National Earthquake Technical Assistance Program. In this module, we'll be going through a class exercise. You're watching the 8th of 9 training videos outlined here. Module 1 was an introduction to the rapid visual screening. Module 2 went over earthquake hazard and seismic performance of buildings. Modules 3 and 4 went over the RVS process. Module 5 covered key building performance indicators. Module 6 and 7 went over the FEMA building types. And Module 8, this module, will be going over class exercise. Looking ahead, Module 9 will provide some concluding remarks.
So in Module 8, we're going to go through some examples in utilizing the P-154 procedure. We're going to start with a few warm-up examples, but prior to that, let's talk about FEMA building types. What are some of the techniques to utilize for identifying the FEMA building type, particularly if you don't have the structural drawings for the building? What can we do to make sure that our selection of the proper building type is correct? So we'll look at that. And then we'll go through a more extensive class exercise at the end of it. So determining FEMA building type. Kind of the logical way to approach it is through your pre-screening data process, and that is looking at how much information can you acquire prior to going out to the field to do the screening. And so some of the sources we've covered in the previous modules, do you have available the structural drawings? That's ideal if you have those. Is there information in the assessor files available there that can give us some information, particularly vintage, on the particular building type? That will help. And some of the other sources are Stanford maps, insurance maps that are available to give us information on the building. We can go to Google Earth and we can begin to look at the building from an exterior perspective before we get on site. We can look at the rooftops, gives us a little bit of information there in terms of plan, the plan footprint of the building. So there's quite a bit of information we can try and gather prior to actually going to the building. And then the other is our exterior survey. The 154 procedure is visual, so you have to go out to the field and walk around the building. If you have access to the interior, particularly those spaces that are unfinished, like mechanical rooms, basements, even up on the top of the roof and penthouses, you can get some idea on structural materials that were used. Is it a wood building? Is it a steel building? Is it a concrete building? To narrow down the actual FEMA building type that the building could possibly represent. And so an interior survey is very, very effective and helpful. And, at the end of the day, if you have access to a ladder, you can, in select locations, actually pop ceiling tiles using that ladder. And then what that's going to do is it's going to expose the entire building structure to you in that area. And we're going to be able to tell quite a bit about the material type for sure, and then hopefully zero in on our lateral system to then provide us to identity for the FEMA building type. So let's look at a few of those in terms of examples. The process we want to try to utilize is eliminate what the building obviously is not in terms of the 17 FEMA building types. And so oftentimes we can almost if we can get rid of a particular material type, we can take away roughly a third or a fourth of the 17 building types right away. And then we can begin our more thoughtful assessment of which ones it potentially could be. Again, interior inspections, if you have the structural drawings, fantastic. We want to eliminate all the building types that we believe it's not. And oftentimes you can then zero in on 2 or 3 potential building types that the building could be represented by. And if you don't know it any further refinement than that, it's very simple to actually go and run all 3, in this case buildings, all 3 scores for the building. Because beyond that, it's the modifiers which are going to apply no matter what. And so if you can apply those modifiers on 3 building types, come up with your final level 1 score and just take the lowest score as representative of that building, and then utilize the data in that fashion, understanding that, you know, I'm not exactly sure what it is, but I know it's one of these 3, and then move on with that in terms of your FEMA building type. So let's kind of do that, if you will. And so here's our first example, and all we're provided is this photograph of the corner of a 3-story building. So we can see 2 sides. It looks very regular on these 2 sides. So we're likely going to be, we won't get into our irregularities. We're just looking at our FEMA building type. And so if we look at this, we see some sort of brick facade at the very front or corner of the building. And then from there, it transitions to sort of a lighter color. And then we have sort of some bump outs, if you will, of the gray materials there that are full height. And those are set outwards in 2 different planes from the actual planar surface of the wall that's set back for the main part of the building. So we kind of have some bump outs, if you will, for the structure. Those are telltale signs that will help us. But what we can, at this stage, decide exactly what this building is obviously not representative of our 17 FEMA building types. So Sarah, which building type do you think the building is not as a start?
It doesn't look like MH, manufactured housing.
Yes, very much so. It's not MH.
And it's also not like a big box warehouse. So that would take out PC1.
Correct. Anything else? How about overall materials in terms of, can we eliminate anything there? Is it wood, steel, concrete, or masonry? Any of those materials we can, you know, systematically take out right away.
Well, I think wood buildings can go up to 3 stories, but I'm thinking it might not be a wood building. I would think it could be concrete. It could possibly be steel, although I'm not sure that that's very likely. And I don't think that it's reinforced masonry with all those bump outs. That seems like that would be difficult construction.
Okay. Well, MH is the nice easy one, right? Doesn't look like a trailer.
Right.
But it doesn't look old either, does it?
No.
So it's not unreinforced masonry, and if it's not old, then it's also not C3, which is concrete with infill, nor is it S5, which is steel with infill. So we can screen those out fairly quickly. How about our S3 building type, which is our light frame Butler building, single story?
It does not look like that at all.
No.
This is
So
multi-story.
We can screen out S3. PC1, you said. How about PC2, which is our precast concrete frame building?
This looks too irregular to be a PC2.
Right, so I think it's safe we can screen out PC2 as well. So concrete right away, we've got 3 of them out, C3, PC1, and PC2. We also have URM, MH, and we have S5 and S3. And then you want to still keep wood in.
Well, it's not a single family home, so it's not W1. You know, it looks like almost like one of those buildings where you have several stories of wood over a concrete garage, but I don't actually see any distinguishing podium type concrete podium here. Right. So probably not wood. Yeah. I agree.
So I think all of wood comes out. So we just eliminated 3. So with those choices, I think I got them right. So W1, 1A2, S3, S5, C3, PC1, 2, URM and MH. We can screen out, you know, nearly half of them right there. Now, further beyond that, we've got, you know, it could be either one of these. It could be masonry, it could be concrete, shear wall, concrete frame with a cladding on the outside, or steel. But my my architectural friends, I do have some, tell me that the surface of this cladding, exterior cladding system, is such that it's not straight or linear all the way down both sides. There's bump outs, if you will, for these different sections. And concrete and masonry don't lend themselves cost effectively to that type of exterior non-linear or planar wall systems. And so they say, no, this is not a concrete C1 or C2, nor is it reinforced masonry 1 or 2, because the exterior surfaces for those buildings are very linear, very straight. So those can come out. S4 is that appropriate? That's our steel frame with an interior core of concrete around like an elevator or stairwell core.
Seems possible, but not the most likely scenario.
Yeah, I don't think we're quite tall enough yet.
Yeah.
For that to be an effective system. So we can screen out our concrete, we can screen out the masonry and the S4, and so we're left with an S1 and an S2, which is our steel moment frame and our steel braced frame. So, and from this vantage point, all the information we know, we can't quite tell which it is. So we can actually run both columns and score both.
I'd be real tempted to take a peek inside the lobby down there and see if there's any evidence of a brace or not. But
Yes.
barring being able to look inside, yeah, it's hard to tell whether it would be a moment frame S1 or brace frame S2.
And so we can easily run those two quickly. All right, so here's another example. So if we look at this exterior photograph of a portion of this building, it looks gray in color. And so just from that alone, which material types can we exclude just from looking at the color of the building? What does this look like?
It looks a lot like concrete. It does not look like brick.
Yes, it's
Yeah.
gray in color, which is concrete, and it's not a trick question. And so we can get rid of wood, we can get rid of steel, we can get rid of masonry. And so we're dealing with concrete. It's not an MH naturally. So we've got a C1 frame. We've got a C2, which is concrete shear wall. We have a C3, which is our older frame with masonry infill. And then we have PC1 and PC2. Well, PC1, it's not a big box warehouse, correct?
Correct.
And PC2 is frame-like. Does this look frame-like?
There is some regularity on that back portion that's inset a little bit with the smaller windows, but I don't see any joints in the concrete. It looks pretty continuous.
Right, so no real frame action. So if we get rid of that, what about C1, which is moment frame?
That looks like too much concrete on the face of the building to be acting as a moment frame. It looks more like a shear wall.
Exactly, so that's what we're left with, which is C2. And in fact, if we were to walk up and more thoroughly look at the exterior surface, we would see actually the planking used for formwork for this building, and which suggests strongly that this is a concrete shear wall building type C2. So yes, very good. If we were to look a little bit further at this example and look at some of the modifiers associated with it, what type of vertical and plan irregularities do we see?
Looks like a re-entrant corner right there. Like the building might be L-shaped in plan. So I would think that that's a plan irregularity. And I think we'd have to look around the building a little bit more to know whether there's more wall on one side than another and how that affects the torsion. But it looks like there's a lot of concrete on that one front face on the left, and then a lot of openings on some of the other sides.
Right.
It also looks like the building's a little shorter on one side than it is on another side. So there might be a vertical irregularity for the out of plane setback.
Yep. And we've got framing that looks like it's possibly framing in at different levels. And so if we take, this is an interesting example in that we have both a severe vertical irregularity, out of plane setback, and a moderate vertical irregularity, which is moderate. And the procedure for 154 is such that we take the most severe of those two selections for vertical irregularity, and that's what we use. So in this case, we would score this only taking the severe out of plane setback modifier. And then plan irregularity, like you mentioned, there could be we've got one side that has some larger openings that create or induce torsion in our building. And so we've got a plan irregularity. So we take that as well. So if we were to score this, we would have C2, which is concrete shear wall. We would have a severe vertical irregularity, which is our minus 0.8. And then we would have our plan irregularity of minus 0.5. And they're telling us it's not pre-code, i.e. a very old building, nor is it post-benchmark, meaning a new building. So our average building in the 80s, 90s type time frame is appropriate, and no soil modifiers. So our type CD soil is appropriate. And so if we add our scores up between our basic score and our modifiers, we end up with a 0.3, which in this case happens to be our minimum score. And that's the one we would then use to represent the P-154 level 1 score for this building.
And it looks like this is looks like the scoring table for very high seismicity. So if this was in a lower seismicity, the score might be a lot higher.
Yes, yes. So we are shaking this building fairly strongly. And that's what the scores are representative of, yes. And we would, here would be the completed data collection form. So we drop a photograph in at the top. We would draw a plan sketch kind of denoting which of the roof elevations were higher and shorter than the other for our out of plane setback, and then information on our building, our modifiers, and then our resultant score, along with our summary down at the bottom of our data collection form. So let's look at another example here. So again, it's similar to our very first one where we have a photograph of the building from the corner so we can see two sides. It's a 6-story building, so much taller than our other one. And we've got an exterior cladding system composed of different colors. There looks like there might be brick at the lower level and then some other, maybe possibly ephes or something on above that. We've got the walls are not planar like we had discussed before in terms of masonry and concrete. So see anything else there that might be some giveaways to identifying our potential building type?
Well, it looks, I'm just counting the stories. It looks like it's about 6 stories. So let's see, too tall to be a wood frame structure. And I'm trying to think if I would just jump right to that S1, S2 answer that we had for the last example, or whether there'd be other options.
Right, for steel. Okay, well, This building happens to be, well, we'll see this in a minute. It's an S1, it's a steel moment frame. But what we're going to look at here is the relative performance between a steel frame building in each of the 5 seismicity regions. And so those regions might be for low, Washington, D.C., moderate, St. Louis, Missouri, moderately high, Helena, Montana, high, Las Vegas, Nevada, and very high in Los Angeles, California. So if we were to take an S1 building type, steel moment frame, and as if it was in each of these areas, and then look at the scores or the basic scores for the building for this, And then here's our slide of showing an interior view of an unfinished space. And we can clearly see that we've got continuity plates at the bottom of our beam at our column, and which is a dead giveaway for a steel moment frame connection. Therefore, we can conclude this is a steel moment frame building, therefore S1. So that is confirmed. We have our building is on the left here in this photograph. The building in the back is a different building, not part of ours. There is a separation we can see clearly on the left. But what about the building on the right? It is a different architectural exterior than the building in the back. We're not reviewing these, but nevertheless, it's instructive to take a look at them. How is that building on the right framing into the building in the back in terms of our floor elevations?
They look to be not aligned.
Yeah, not aligned. So that's one of our adjacency criteria we walk through, right? Is are our floors aligned between the two separate building types? They look like they're separate because they're different architectural exteriors. And then the floors don't align, so we don't have horizontal mobility between these two buildings, again suggesting they're two separate buildings. And so these, if we were to evaluate these two buildings, we would have to evaluate them for pounding, which if you look at it, it doesn't look like there's much of a gap in order to evaluate for pounding. Okay, so our building on the left is a steel moment frame. We were going to drop it into each of these 5 seismicity areas. And this, they're telling us we have a planned irregularity. They're also telling us that it's post-benchmark, which means it's a newerly designed and constructed building. And they are telling us also that we are on a type E soil. And now we have to look at building height and to determine appropriate soil parameter, and we're greater than 3 stories. So we use that soil type E modifier. And then the minimum score is provided, and then we have our final score at the bottom. So if we were to score a steel moment frame building in each of our 5 seismicity regions, given that information, notice our final score is 3.4 for low, 2.3 for moderate, moderately high is 2.1, high is 2.1, but very high is 1.7. And so with 2.0 being our cutoff score for basically life safety, the building essentially passes that model, except for very high seismicity. So my question to you, Sarah, is, and this is instructive in regard to that, if I have a newer building, which is reflective of post-benchmark activity, would I not expect that building to satisfy or pass the P-154 criteria as sort of a data point on terms of its viability?
You know, I think that the scoring is based on numerical analysis of different building types and how these different key performance indicators affect the chance of collapse. And I think that based on this methodology, you know, the very high seismicity and this building scores a 1.7, so it's below the cutoff of 2, which means that it would get sent. It doesn't mean that it's going to collapse. It just means that it doesn't get screened out of the pot of buildings that we might be concerned about. So in that respect, it's appropriate that it's got, you know, it's on the very poor soil and it's got a plan irregularity. And so we don't want to say like, it's okay no matter what. However, if you're planning a RVS screening program, one thing that you might want to consider is saying, we know that in our community over the last 15 years, we've had really great code adoption and really great construction quality assurance programs. And so we're not worried about our newer buildings. And so it could be something that as a program, you might want to decide not to expend your resources on these newer buildings.
Right, good point. the fact that it sort of provides, validity of the 154 procedure. If we had a new steel moment frame building that didn't pass our criteria, I would have very severe questions about, how I use that if a new building won't pass the criteria. And in fact, all of these seismicity regions, the building does pass. And here's what I'd like to point out. Post benchmark means this is a newer building built to newer codes. And part of that, as you know, for the design provisions is if we have a poor soil type, our building foundation system is designed for those poor soils. And so I always like to look at it. If I take this vulnerability out from the soil type of minus 0.3, what does my score become for the building?
2.0.
2.0. I'm essentially there for very high seismicity. So, I mean, that's kind of how I look at the scoring with the 154. I got to believe the engineer designed the foundation associated with type E soils, and it was incorporated. So why penalize them?
Mm-hmm.
So I think it actually meets in all regards. So, but it's good to kind of benchmark the procedure to see that it doesn't truly work. It's not overly conservative and conversely under conservative. All right, here's our class exercise where we'll go dive into it a little more deeply in terms of how to do a field screen and then how do we walk through and complete the forms. And so here is a building that we have in Anchorage, Alaska. What we want to do is go through and we'll select the proper data collection form. Then we're going to have a Google Earth video that does an exterior walk around the building and then looking at the elevations. And then where we're going to ask you to actually go through and begin to fill out the form, how you might complete your review based on our exterior Google Earth review. And we'll calculate a final score and then kind of see what you ended up with relative to what we ended up with on the building. So with that, let's start. So the first step is, which form do we use? And if you recall in our previous module where we have to determine the region of seismicity for our building, that building or the ground motion level that we actually utilized was for a building in Anchorage, Alaska. And if you recall from that, that was very high seismicity, just barely above it. But if we use the maps out of the P-154 handbook, we can see that Anchorage is in the very high seismicity region. So both yield the same results. And so we would select the very high seismicity form. So that's the one we're going to be using. So the elements that we're going to be looking at as we walk through the building, it's a 1998 vintage. So keep that in mind. What we want to assess is that, the occupancy category, that's not part of our scoring, but it helps us in terms of the post-field planning aspects in terms of developing mitigation programs. We're going to try to address our pre-code and post-benchmark score modifier. We'll look at soil type. If we don't know it, then we assume a type D, unknown. As we walk around the building, make sure you look for falling hazards, things, appendages or whatnot that could be falling hazards if the building is shaken. We're going to look for any buildings adjacent to our building where we might have to address pounding. Take a look at the building. It's, like I mentioned, 1998. Do we have any damage or deterioration of the building? And then we're going to hopefully be able to narrow in and determine our building type or types. As you walk around, also look for plan and vertical irregularities. And then once we understand those, we're going to then select our score modifiers. And from there, we should be able to calculate our final level 1 score. So here's a short video walking around the building using Google Earth. And so right now we're looking down right on top of the building. And I think my cursor works, but this is our building. So we're looking at this center building right here. So to get your bearings straight, And so I'm going to go ahead and play this, and we're going to do a walk around. Sarah, you want to narrate as we do that?
Yeah, I will just tell you what I'm seeing.
Okay, here we go.
All right. It's got a lot of stories, definitely more than 10. And it looks like there's a low roof, a couple of low roofs. And so I see some corners on the interior of the building, some re-entrant corners that might be a plan irregularity. Looks like there's a small building right next to it in front of us that might be an issue. I see that that first story looks a lot taller than the upper stories. Maybe the first 2 stories look taller than the upper stories. Got a lot of glass and maybe columns on a pretty regular plan. Oh, and at that bottom corner, I see something diagonal. Again, I see some offsets where there's a low roof and then higher roofs. And sort of an L shape for that tall tower.
Right. So we definitely have a re-entrant corner associated with that. That's one of our plan irregularities. Okay, after our Google Earth review around the building, here's some selected photographs or screenshots of the building on various sides. So here we can kind of get a good idea of, we've got what type of vertical irregularity, Sarah, that we see here. We've got a taller portion of our building and then a low roof section.
Looks like an offset, a vertical offset.
So we got an out of plane setback.
Yes.
In this face, let's walk around the other side. We're kind of down to the right-hand side of this same view, but looking up.
And the taller lower story versus the upper story looks like a weak or soft story. Vertical irregularity.
At the base, right? Yeah, we have a taller story.
I'm also trying to figure out what kind of building type this is.
We'll get there. And so here's our corner as we kind of walk around the corner, and you had mentioned earlier about a diagonal element at the ground floor. And so here's that diagonal element. And the key thing I always like to look for is this is exposed. We can see it's diagonal, correct?
Mm-hmm.
But if we look above this to the structure, we can see that it's solid all the way up. There's no windows on that portion of the building. And so that's kind of a telltale sign too. I think it's a better view here. So we have, again, this around the side of the building, we've got some very large areas with no windows, so we can put structural elements in for a lateral system. It's kind of a good sign.
So if it was a moment frame, there might be a lot of windows.
Correct. And so here's kind of the backside, and we see kind of evidence of that again, where we've got some pretty large areas of no windows, no penetrations, and it's vertically stacked very nicely. Again, it's a 1998 building in a high seismicity or very high seismicity region, so very likely it's going to have had some seismic design attention, and so one can somewhat conclude that's why there's no windows there. They've done something structurally. And so here's our form. And so we're go ahead and pause the video and then go ahead and take an attempt at filling out the form. And we'll kind of come back. So building type, identify building type, identify the vertical and plan irregularities for the modifiers, assess whether it's pre-code, whether it's post-benchmark, again, knowing our vintage, and then soil type, again, from the information that you know. All right, so here's our form. And so we're going to go ahead and walk through filling it out. And so here's, we might drop in a photograph of the elevation up at the top, and then in lacking a plan review, let's just take a Google Earth snapshot and we'll put that as our plan sketch to illustrate. We've got, looks like some differential roof heights, as well as our plan shape of the building is not quite truly rectangular, particularly for our changes in elevation, right?
Mm-hmm.
And so starting off with our form, we're looking at pre-screening. We determined that there are no geological hazards. So liquefaction, settlement, or landslide, we have no geological hazards. Again, these are not scored, but we do record them for our building. Are there any vertical irregularities that we see? Sarah, what do you think?
Yes, there's the out of plane setback, and that is severe.
Okay, so we have a severe out of plane set or vertical irregularity out of plane setback. So on our form, as we'll see, we'll record that on the upper section and then record the actual modifier below. And are there any horizontal irregularities that we saw during our walk around?
Yeah, so that tower, the taller part was sort of L-shaped in plan. So I would say that that's a horizontal irregularity for the re-entrant corner.
With the re-entrant corner. Okay, so we've got vertical and horizontal now. So any falling hazards did we see as we walked around?
I didn't notice any. There weren't many appendages on the side of the building or things sort of
No,
hanging
the
off of it.
cladding was very linear all the way around and up. And yeah, there was no cantilever elements or anything there. I agree. So no real serious falling hazards did we see. And so here's our middle section of our form, showing our soil type, geological hazards, adjacency, and falling hazards, and our irregularities. We record them there, and then exterior falling hazards. So our soil, we don't really know what it is. So it's D, and that is what we should assume if we don't know anything about the building. So D. And then the geological hazards, we would record those as no, because our pre-field planning identified none. Do we have any adjacency issues? We didn't see any. There was that small building, but I think there was separation between our main building. The one view you commented on, it looked like it was right against it, but the rear view to me looked like there was a gap. And so I don't think we have an adjacency problem. Our irregularities were vertical, out of plane setback, and plan re-entrant corner. So yes, we have those two. So we'll have to score those. And we didn't notice any exterior falling hazards, other than could be heavy cladding or veneer, right?
Right.
Although it all looked good. So from that, though, what is our FEMA building type? That's kind of key. So we do have some assistance from FEMA 154 in the handbook, in that they provide tables of the various building types relative to the number of stories as to what the building type is more likely to be. And in this case, we're showing commercial. It's a commercial building. And so what they're suggesting in here for newer buildings post 1960 is that for buildings of 15 to 30 stories, it could be an S1, which is our steel moment frame, S2, which is our steel braced frame. It could be a C1, which is concrete moment frame. It could be C2, which is concrete shear wall, or it could be PC2, suggesting it might be a precast concrete frame building. And actually S4 could be one of these, fall into this category as well. Okay, so those are kind of our choices, what it might be. If we look at our 17 building types and kind of go through our exercise again, we know it's not wood, correct?
Right.
We know it's not URM or MH, correct?
Yes.
it could be our PC2, which is one of our choices in our table, as well as C1 or C2, S1, S2, and S4. S5 is older, C3 is older, so those screen out. So those are the ones that we can screen out right away. And so we're kind of left with these 6 choices for our building. But what are some of the telltale signs that we saw as we walked around the building to even allow us to hone in a little more closely on what type of building this is?
Well, we see the flat spaces with no windows, which indicates that the lateral system is probably back there, and it probably is obstructing like where windows would go. So that would not be true of a moment frame. A moment frame, we could still have a lot of windows there. So I would say that it's not an S1 or a C1, so a steel moment frame or a concrete moment frame, or a PC2, which is the precast frame.
Right. So leaving us with S4, S2, or C2.
Yes, and I recall seeing that diagonal. So if that diagonal is indicative of there being braces behind the cladding, then that would be a steel braced frame, an S2.
Right. So, and it goes all the way up. So there's a photograph capture of our brace, and we have no windows above that, suggesting we can put whatever brace we want that's likely behind that cladding system. And so we end up with an S2 in terms of our building type. Very, very likely. So S2 is what we would select for this building. And so if we look at our benchmark years associated with this building type, the P-154 document provides us a table based on the building code that was used for design, the vintage. Then we just come in and compare to the table for our particular building type, and we can arrive at a decision as to whether this is a benchmark building or not. So we have an S2 steel brace frame, and for Alaska, that would have been, they utilized the UBC back in the 90s. And so our building is a 1998, we said. And so the benchmark year is 1997 for steel braced frame. And so one of the things we do want to remember, though, is this was the building designed to the 97 UBC, or was it an earlier building code because it was just completed in 1998?
I would guess that it took a couple of years to design and construct that building. So if it was completed in 1998, it probably was designed for the previous building code, the 1994 UBC.
I agree. So we don't have a post benchmark. So our basic score applies in this case. Okay, got that. So here's our filling out our form. So this is our upper section about our building. It's in Anchorage. It's our example. It's a hotel, so that's our occupancy. There's our lat long. We have our ground motion parameters that we've collected. We're the screeners. We went around it. We've got 21 stories, nothing below grade. Interestingly, it's 360,000 square feet, 1998 vintage. Code year was 94. And if we look at additions, there were none, and we are a commercial building. So that's our upper portion of our form, how we might complete it. Here's our scoring section of the form, and what we decided was this is an S2 building. So there's our basic score, and we had a severe vertical irregularity, correct? And then we also had a plan irregularity. We're not pre-code, nor are we benchmark. And we said our soil type was D, so we don't have any modifier for A or B or E. And so our final score ends up being 1.4 plus a minus 0.7 plus a minus 0.5. We're at 0.2, but our minimum score is 0.5. So the minimum of 0.5 is what we would use for our final level 1 score for our building. So hopefully everybody got that score. And you can imagine how the score would be quite a bit different had you had selected a different building type. And so that becomes the challenge with this procedure, is to making sure that you do have the correct building type representative of your building under review. So this is the bottom part of our data collection form for our screening summary. And so this area on the far left-hand side, lower left of our form, records the extent of our review. How thorough was it? It gives us some idea from anybody picking up the form later as to what was done. And so for our review, what we did was we looked an exterior review, all sides. We also did an aerial via Google Earth in terms of our review. Did we go in the interior? And the answer is no. We did not do an interior review. Did we have drawings available, structural drawings? No, we weren't able to find any. And then we have information on our soil type, our geological hazard source, and did we contact anybody? And so our soil type, we'd use the default D because it was unknown to us. And for the geological hazards, we said we had none. The USGS was our source for that, and then we didn't contact anybody. And so the last part is, did we do a level 2 screen? And our answer was no, we only did a level 1. If we move right on our data collection form for our screening summary, our other hazards is the center box, and that addresses whether we had any adjacency and then pounding issues for our building. And we identified that we had no adjacent buildings that were close. Did we have any falling hazards? We decided we didn't have any. Geologic hazards or soil type F, we used assumed D, and we had no geological hazards. And we decided we didn't have any significant deterioration. The building looked fairly, it was new, 98, as well as looked in good shape as we walked around it. And so our other hazards would be none. And then our final summary would be action required for both building and non-structural components. And so our score was a level 1 score was 0.5, which is less than our standard cutoff score of 2. Therefore, our score would be, this action required be yes, our score is less than the cutoff. And then for non-structural components, we didn't go inside, so we didn't really address those. And so that would be D and K, which is, I do not know. So any final comments regarding completion of the form, Sarah?
I think that we did a very thorough job. I would say, you know, in this example, we looked at Google Earth and some photographs, and actually being on the ground, walking all the way around the perimeter of the building would have been essential for really understanding all those adjacency and pounding issues and getting a real good sense of the building. So it can be tempting to just use Google, but being on the ground, actually walking around the building, we're going to see a lot more stuff.
Yes, very much so. And the P-154 procedure really wasn't designed to be a Google Earth review only. Let's take a real quick quiz then. Is this building, if this building were in a location with a lower seismicity, the final score would be different, true or false? So we're in a very high seismic region, shaking the building very strongly. If we took the same building and plopped it down into a lower shaking environment, would our score be higher or lower?
I would think that the score would be higher, indicating that there was a lower chance that the building would collapse in an earthquake. So I would think the score would be different.
Yes, it would be different and would be higher. Yep.
Thank you, Mike and Sarah. So the next module, Module 9, Sarah will conclude this training series going through additional tools, resources, and some final remarks. This concludes Training Module 8, the FEMA P-154 class exercise. We hope to see you in the next and final training video.